Alright, in today's video we are still going to be looking at ratios and proportions, but we're going to be looking at applications of these and how are we going to see these in word problems and how should we apply these. So our first word problem, a basketball player started the season making 5 out of every 12 two-point shots. If he continues this way for the entire season, so if he continues along this trend making every 5 out of 12, how many two-point shots will he make if he shoots 600 shots? So what we want to do is we want to establish a relationship, a ratio showing that relationship. We start with what we know. We know that he's going to have 5 shots made. That's what he's going to do good out of 12 shots total. This is going to set up that relationship. So on the numerator of my fraction is how many we're making. On the bottom is how many that we are taking. So in the end, we want to find out how many is he going to make. The key there is how many he's going to make if he shoots a total of 600 shots. So as we go to our next fraction, we want to think about where is that other number that we're given, 600. Is that going to go on top? Is that going to go on the bottom? The number on top is how many you're making. The number on the bottom is the total. So the 600 is representing the 600 total shots that were made, and we're trying to find out, or the total shots taken, we're trying to find out how many were made. Now that we have taken our word problem, we have analyzed the information, organized it in a way that we can solve. Now we're back to where we were yesterday with solving a proportion, two fractions that are set equal to each other. So we cross multiply. 5 that were made times the 600 is equal to the 12 times the x. So that gives us 3,000 is equal to 12x. We want to isolate x, and that tells us that x is going to be 250. So that's going to tell us if he continues this way, he will make 250 two-point shots out of 600 total. All right, because we have a word problem, depending on the directions, maybe the directions didn't ask you to write out a full sentence, that's fine, but you would still have to label your answer. What is the 250 made representing? It's 250 made shots. Anytime there's context or information representing what those numbers mean, then you have to label your answer. All right, our last one. A diagram of a bookcase in an instruction booklet uses a scale of 2 centimeters to every 15 inches. So on the drawing, anything that's representing 2 centimeters on that drawing on your paper is going to represent 15 inches in real life. If the diagram is this tall, this wide, and this deep, what are the actual dimensions of the bookcase? So we want to work with what we know. What we are given is the scale of the drawing to real life. So it's really important that when you create your fractions or your ratios, you are labeling what you are putting where. So 2 centimeters, 15 inches. This is representing the drawing. This is representing real life. So that when you go to put numbers in, you know whether it goes on top or on the bottom. So we have to do this in 3 steps. We are told that it is 7.8 centimeters tall. We are given centimeters, so when I set up my ratio, that 7.8 is going to go on top because the way that we set it up, centimeters were on top, inches were on the bottom. Now you could have done inches on top and centimeters on the bottom as long as you are consistent the whole way. Whatever measurement's on top here, that measurement's on top there, on the bottom there. So we want to find out what is the actual height of the bookcase. On the paper, it's 7.8 centimeters. We cross multiply. 2x is equal to 15 times 7.8. 15 times 7.8 is 117. We divide by 2, and x is going to be equal to 58.5 inches tall. Again, make sure that you label your answer so we know what that number is representing. We have 3 different dimensions here. We have height, width, and depth. So I want to know and label correctly that I am representing 58.5. It's inches, not centimeters, and that we're talking about the height of the dresser. This is the scale that's going to be used for everything. So the height, the width, the depth are all going to use that 2 to 15 scale. So we set up the first ratio the same. And this time we are looking at the width. It is 5.4 centimeters wide. And we want to find out what is the actual width of the dresser going to be. Just like before, we're going to cross multiply. So 2 times y is equal to 15 times 5.4. 15 times 5.4 is going to be 81. We divide by 2, and we get y is going to be 40.5 inches wide. All right, what I want you to do now is to press pause. And I want to see if you can correctly set up the right proportion to solve for the actual depth of the bookcase. So go ahead and press pause. All right, let's see how you did. The scale again is 2 centimeters to 15 inches. The depth is 1 centimeter. We are trying to find the actual depth, and we should have used a different variable here. So let's use z instead. Go ahead and press pause again, and let's see if you can correctly solve for z in your proportion. Okay, go ahead and press pause. All right, again, to solve your proportion, you are going to cross multiply. So when you cross multiply, you then divide by 2, and you get that the depth is going to be 7.5 inches. All right, and that is the end of today's video.